The final type of passive process across a cell membrane is facilitated diffusion. Now, your book actually combines facilitated diffusion with the two active processes. That is because they've combined them all as a carrier-mediated type of transport. Try to look at it both ways because I think that's really the best. You've got passive processes that do not use ATP. That's going to involve diffusion, osmosis, and now facilitated diffusion. And then you've got active processes that are going to be your active transport and vesicle transport. But vesicle transport, active transport, and facilitated diffusion all require some type of carrier. And this is how those three fall under carrier-mediated transport. As you can see here, this carrier-mediated transport doesn't require ATP. It relies on the concentration gradient or the difference of the amount of molecules between the extracellular fluid and the intracellular fluid. You can see here that there's all these red dots that are in a high concentration in the extracellular fluid, and there's only 2 inside, and so those molecules have a driving force. They want to go inside, and the only way they can get in is through this handy-dandy membrane protein that actually has a spot for them and fits for them. Remember, I mentioned that some of the proteins that are involved in transport, they're going to be specific. They have that characteristic of being specific. They have specificity. They're only going to allow the molecules they're made for to pass. You can have things, this happens with molecules like glucose, amino acids, sodium, potassium. They're specific carriers or just channels that will open up and allow molecules to go through, and again, do not require ATP. These carrier proteins, just another characteristic that you should know about, they, of course, conform to the shape of the ion or the molecule that they're getting across the membrane, but they can get them across the membrane in different directions. So when we talk about one carrier protein getting a molecule across in one direction and one molecule, then it's going to be uniport, as we have here on the right-hand side. Symport is a carrier protein that's going to carry 2 different molecules, but simultaneously or together through the carrier protein. Antiport is a carrier protein that's going to carry one molecule in one direction and another molecule in the exact opposite direction. So those are different types of transportation that can occur through these carrier proteins.